All right, everybody, today we're going to look at 6.1 relations and functions. So we're going to list ordered pairs of relation, determine whether relations are functions, and describe a mapping diagram. All right, go ahead and do your warm up. Hit pause when you're done, come back and check your work. For 1, you should have ended up with 11, or x equals 11 and 4/10. And for 2, remember, if it's a fraction, keep it as a fraction. X equals -3/5. All right, when looking at functions, what we're going to do is we're going to take a look at these ordered pairs. Now, ordered pairs can be used to show inputs, which is your x value, and outputs, which is your y value. So our inputs are 0, 1, and 2. Those are our x values. Now, 1, 2, and 4, those are our outputs or y value, meaning I input a 0 in an equation and I get a 1. Now, this ordered pair is actually called a relation. So, meaning I put in a 0, I get 1. This is another relation, and this is another relation. Now, I can show those relations by ordered pairs or by this, which we call a mapping diagram. Now, that mapping diagram will point to your ordered pairs. So if you look, we have 0 to 1, 1 to 2, 2 to 4. My input's my x, my output's my y, my first value is x, my second value is y, and you will notice this is the same information. So looking at example 1 here, how can I use this mapping diagram to write in ordered pairs? Well, I'm just going to follow these arrows. So I have 1, 3, 2, 6, 3, 9, 4, 12. Here it's not quite as neat, but I'm just going to follow those arrows. So I have 0, 0, 2, 1, 2, -2, and 4, -3. All right, on your own, go ahead and do 1 and 2. Hit pause, come back when you're done. All right, let's see how you did. You should have 0, 12, 2, 10, 4, 8, 6, 6, 1, -1, 1, -2, 2, -3, 2, -4. Now you'll notice this input has 2 outputs. As we're here, each input has its own distinct output. This is what we call a function. We've got 1 input and 1 output. This is not a function, meaning we've got 1 input and 2 possible outputs. So a relation that pairs each input with exactly, I gotta spell that right, exactly 1 output is called a function. So are these functions? Well, if I look, I have -9, 0, -2, 5, 5, 10, and 12, 10. Does each input have 1 output? So -9 only has 1, -2 only has 1, 5 only has 1, 10 only has 1, or 12 only has 1. Now I know these are repeated, but that's okay. All I care about are my inputs, meaning does my input only have 1 output? So since my 5 only has 1 output and my 12 only has 1 output, this is a function. Why? Because each input has exactly 1 output. Yay! Now let's look at this bugger over here. So I have -2, 3, that's -2, 4. You got to watch those arrows. -1, 3, 0, 5, 0, 6. Look at that. It's got two different outcomes. 1, 6, 2, 7. So this right here, I know I don't have a function. Not a function. Why? Because 0 has two outputs. Sad face. Right? So each input can only have one output. So let's consider this mapping diagram. Determine whether each relation is a function. Well, if I look, each input has exactly one output, so this is yes. Each input has exactly one output. Now let's describe the inputs and outputs. So just looking at the inputs alone, I notice that I'm adding 1 each time. Now looking at the outputs here, I can see I'm adding 15 at a time. Now sometimes there's a pattern, sometimes not so much, and that's okay. So if I were to describe this, each input increases by 1 and each output increases by 15. All right, on your own, 3 and 4, go ahead and tell me whether or not these are a function. Now I'll have to tell you this is negative 1/3 or 1/2, and this is 1/3. Sometimes when I copy, those don't show up. So go ahead and hit pause and let me know, and then hit play when you're done. So this first input has two outputs. The second input has two outputs, so this is not a function. Since each input has exactly one output, this is a function. All right, everybody, great job. Have a wonderful day.